I'm Dr. C. Christy, Assistant Professor from Computer Science Department, St.Joseph's College of Arts and Science, Autonomous, Cuddalore 1. This presentation, let us see about satellite components. The component of satellite consists of two segments. One is space segment, another one is ground segment. This is the picture for satellite components, space segment and ground segment. Space segment consists of satellite, tracking, telemetry and telecommand. Ground station consists of earth stations, SCC, that is antennas. The uplink and downlink of users' information can be done to the space station through this antennas. First, we will see what is ground segment. Ground segment basically consists of an earth station. Earth station provides a complete uplink and downlink chain for the signal. It transmits and receives the signal to and from the satellite. It also consists of antenna. Since the user baseband signal cannot be transmitted directly, it also consists of amplifiers, modulators and demodulators, frequency up and down converters. This is the picture for satellite, earth station, uplink and downlink chain. This consists of the following process. The user information uplink to the satellite through this antenna. The same way it will downlink to the another end of the user or output through the antenna. For this process, it consists of the following steps. The user generates the signal to be transmitted is known as baseband signal. This baseband signal consists of video and two audio subcarriers and energy dispersal signal. After modulation and up conversion, the carrier is amplified and uplinked through solid parabolic dish antenna, that is PDA. Downlink signal can be received through same PDA using a trans-receive filter and low noise amplifier LNA. After down conversion to 70 MHz, it is demodulated to get audio and video signal. And next, we will see various types of antennas. Parabolic dish antenna, prime focus antenna, Cassegrain antenna, Gregorian antenna, and offset fed antenna. First, we will see the parabolic dish antenna. It is an antenna that uses a parabolic reflector, a curved surface with the cross-sectional shape of a parabola to direct the radio waves. The most common form is shaped like a dish and is popularly called a dish antenna or parabolic dish. Prime focus antenna. This is the picture for prime focus antenna. It also called parabolic antenna, in which the curve of the dish is known as parabola. The LNB, that is low noise block converter, will be set up at the focus of the antenna. When we use this antenna to search the satellite, we need to know the receiving elevation angle for the satellite. Next is the Cassegrain antenna. This is the picture for Cassegrain type antenna. It consists of the reflector that is built on the concept of using two reflectors, that is namely primary reflector and secondary reflector. Primary reflector is on the form of parabola and secondary reflector is in the form of hyperbola. And the fed is placed along the axis of the parabola using around the vertex. Gregorian antenna. It is the parabolic antenna. In this, the feed antenna is mounted at the or behind the surface of the main parabolic reflector and aimed at the sub-reflector. This antenna is used in radio telescopes and communication satellites. Offset fed antenna. Here the feed is outside the path of the wave, so there is no pattern deterioration due to aperture blocking. The horn faces upwards relative to the axis of the parabola and the lower half of the parabola is removed. The next effect is that the parabola is shallower with a larger focal length. Next component is space segment. It consists of satellite. Satellite has various transmitting and receiving antenna, transponders and other control systems like temperature control, power supply control, orbit and altitude control, tracking, telemetry, command and equipment, etc. Next, we will see various types of satellite orbit on the basis of altitude. An orbit is the path that a satellite follows as it revolves around Earth. In terms of commercial satellites, there are three main categories of orbits. That is LEO, low Earth orbit, MEO, medium Earth orbit, GEO, geosynchronous orbit. Next, we will see what is a LEO, MEO and GEO. First, we will see LEO. LEO is low Earth orbit. It is 1000 to 2000 km above the Earth. These orbits are much closer to the Earth, requiring satellites to travel at a very high speed in order to avoid being pulled out of orbit by Earth's gravity. The LEO satellite can circle the Earth in approximately 1.5 hours. That is 1.5 hours. MEO, medium Earth orbit. It is 5,000 to 20,000 km above the Earth. These orbits are primarily reserved for communication satellites that cover the north and south pole. MEOs are placed in an elliptical, that is oval shaped orbit. Next is GEO, that is geosynchronous orbit. It is 35,786 km above the Earth. Orbiting at the height of 22,282 miles above the equator, the satellite travels in the same direction and at the same speed as the Earth's rotation on its axis, taking 24 hours to complete a full trip around the globe. Thus, as long as a satellite is positioned over the equator in an assigned orbital location, it will appear to be stationary with respect to a specific location on the Earth. A single stationary, that is geostationary satellite can view approximately 1/3 of the Earth's surface. This is the diagram for 3 geosynchronous satellites, how it covering the entire Earth. Thanks for watching this video.